Okay, so then another type of problem involving the vertex is where we want to maximize the area of a rectangle or some closed shape. But rectangles are, for our purposes, what we'll focus on. This is known as the fencing problem. If you take calculus, you will see this problem again. So it's good that you're seeing it now, get some background on it. So the situation is the city wants to make a park by fencing off a section of riverfront property. And the goal is to use all 80 meters of fencing that are available. The area will be a rectangle, but only 3 sides will be enclosed by the fence. So we want to maximize the area given these constraints, and we have to use all 80 meters of fencing. So first thing we should do is draw a picture, making sure that we can visualize what is happening. So we have the river, and we know that's serving as one side of this rectangle here. This rectangle will have a height of h and a base of b. Third side is also h, since opposite sides of a rectangle are congruent. So those are the 3 sides being used for fencing. Now our goal is to maximize area, so we need an area equation. The area of a rectangle is well known. Based on the figure, the area is just base times height. So it's good that we know the formula, but the bad news is this is in 2 variables. It's really hard to work with equations that are in 2 variables. So to turn into 1 variable, we also need an equation for the total length of the fence, which we know is 80, right? We're using all 80 meters of fencing. So based on the figure, we have the perimeter equation as 2h plus b, right? H plus h is 2h, b is the third side. This perimeter must equal 80. So with this equation, we can solve for b by subtracting 2h from both sides. So b equals 80 minus 2h. So the reason we solve for b is because in question 3, it says find a of h, the area of the rectangle in terms of its height h. So we're going to replace b with 80 minus 2h, so that our area equation is in terms of 1 variable, and that makes it so much easier to solve for whatever we want. Solve for h, let's say. And then we could use h to then solve for b. Okay, so then a of h is, replace b with 80 minus 2h. So it's that expression times h. That's the area in terms of its height, h. Now normally we would actually multiply this out and distribute the h, but we're not going to do that just yet, because we want to find the vertex of a of h now. Remember, the vertex is where the maximum value will occur. And before we do that, we will multiply it out, but you don't have to. This is just for demonstration purposes. So when you multiply it out, you get 80h minus 2h squared. In other words, it's 2h squared plus 80h. So now it's in standard form. Before it was in factored form. And notice that the a value is negative. So the parabola will be concave down, and there will be a maximum. So this is like a way to quickly verify that you're on the right track, because we're trying to maximize area. So our function better be concave down, right? The a value better be negative, otherwise we're doing something wrong. So by putting in standard form, we can clearly see that we're on the right track, because it will have a maximum based on the a value. Okay, but we want to stick with factored form for right now. Going forward with solving the problem, because we want the vertex. And as we saw in the previous problem, the vertex is halfway between the zeros. So we gotta find the zeros. And factor form is good for that. So this is just zero product property. So either h is 0, already solved for, or should get h is 40 from the other equation. Because 80 minus 2 times 40, well, that's 80 minus 80, which is 0. So these are the zeros. And so the vertex of A of h must occur halfway between the zeros. So 40 plus 0 over 2. In the end, you should get 20. So the vertex will have coordinates of 20 and then A of 20. A of 20 would be, so doing 80 minus 2 times 20 times 20, you should get 400. And 400 is the maximum area. 400 meters squared, I should say. Did I do that right? My apologies, 800. I had no idea how to do math. 800 meters squared, that is the maximum area. Okay, so at a height of 20 feet, the maximum area is 800 square meters. Now, if you looked at the top of the page, there is this formula that gives you, in this case, the h coordinate of the vertex, or the x coordinate, whatever the problem is. That formula could have also given you that the height has to be 20. Because if you do, so h is negative b over 2a, b and a come from standard form. So you do need standard form for this. You would be doing negative 80 over 2 times negative 2, which is negative 80 over negative 4. That's how you also get 20. And then a of 20 is still 800. So that's another way to find the vertex using that quick little formula there. And again, we know this is the maximum because in the standard form, the a value is negative. The parabola is concave down. Okay, so summarize, you draw a picture, you write equations for the area and total length of the fence. Okay, you need that extra constraint because you cannot solve an equation in 2 variables. So the perimeter equation lets you solve for b. That allows you to find a in terms of h, and then either find the zeros and find that halfway point between them to get the h coordinate of the vertex, and then plug that into the area function to get the max area, or use this little vertex formula to get the h coordinate as well. Okay, and then you have some practice to do, because practice is a good thing, whether you know it or not. All right, thank you for watching. Go Riders.